IB Physics 2026 May HL Paper 1B. I've searched the complete YouTube and there is not a single video that contains the complete solution of this paper. Not a single one. So here it is. Every single question solved completely with full physical reasoning, not just the correct answer. And if you just sat in this exam, then you are at the right place. Now, if you are preparing for future sessions, then here is the most recent and real IB Physics exam paper. And there is no better preparation than working around this paper question by question, step by step. So let's get straight into it. Guys, this is IB Physics HL Paper 1B, 28th April 2026 session, and it is of time zone 1. So let us start this test and let us analyze the question number 1. So you can see that a student investigates the density of a type of a wood and the density of liquid. And in this investigation, the student suspends a solid cylinder made up of wood from a force sensor. This is a force sensor. And this cylinder is partially submerged into the liquid. Okay, and this liquid along with the container is placed on a stand. Now, when a length x of the cylinder is inside the liquid, the force is indicated by the cylinder is by the sensor is F, and the student varies x using this stand. The height of the stand can be adjusted. Now, in the first case, student records the value of F against the value of x, and the relationship is which is observed by him is F is equal to F naught minus rho L A G X, and this is the graph as drawn by him. So F naught is the weight of the cylinder and rho L is the density of the liquid, as well as A is the cross-sectional area of the cylinder. Now we have to suggest in question number 1 that suggest with reference to the gradient and intercept that how this graph supports this relationship. See, we can see that in the first case, you can see that graph is a straight line. So graph is a straight line and it is going down and not passing through origin. Not passing through origin. So we know that in such case, for a line which is going in the downward direction and not passing through the origin, the equation is y is equal to minus mx plus c, and therefore slope of this line is negative, so it is minus m, and intercept of y-intercept of this line is positive, that is c. And if we compare this with equation f is equal to f naught minus rho L A G X, then we can see that exactly this equation follows the straight line equation of which is going down, and we can compare and we can say that the C is f naught in this case, and the slope is obviously negative. It is minus rho L, which is the density of liquid, Ag. This is the slope. So this graph is perfectly aligned with this equation, and this equation represents this graph only. Okay, so this is the first answer. Now let us move on the B part. Now in part B, you have to find out the gradient of this line. So gradient is obviously, we know that it is slope, and therefore if we just carefully observe the graph, we can mark 2 points. Let me mark this as A, and let me mark this point as B. So you can exactly see that A point is meeting at 6 and B point A is meeting at 6 while B is meeting on 5 on y-axis. And if we see the projection of A on x-axis, then it is this point, and the projection of B on x-axis, then it is this point. Now you can see that this is delta y, and delta y is 1, 6 minus 5, and this is delta x, and delta x is 0.05. Okay, so the gradient of this line, I have already marked these points. So observing, yeah, so observing the points, A and B on the graph, which we have marked, we can say that the gradient of the graph will be delta y by delta x, and with a negative sign, due to the fact that this line is going down and therefore slope is negative. So we can say that gradient will be delta y, which is 1, and delta x is 0.05 in meters. Okay, so 1 upon 0.05 will be 20, and unit will be Newton per meter. So this is the gradient of this line. Now let us move on the section C. And obviously there would be a negative sign also. So the gradient will be minus 20. Now let's discuss the section C. In this part C, we have to find out the density of liquid rho L. Now we have already calculated the gradient, which is minus 20, and if we compare this gradient with this equation, then the value of gradient will be rho L Ag. So this is rho L Ag, and this is a negative sign also. So 20 is equal to rho L Ag. Now rho L will be equal to 20 upon Ag, and the value of A will be pi r square, and G is G. Now pi is 3.14 and R is given as 0.028 and G is 9.81. So the value of rho L will be 20 upon pi, which is 3.14. R square is 0.028 whole square, and G is 9.81. So the value of rho L will be equal to approximately 830 kg per meter cube. This is rounded off to the nearest integer. So this is the density of liquid. Now we move on the next part D. Now in this part D, we have to find out the ratio of density of wood to the density of liquid. Now for this, let us again discuss the point A. So you can see that at point A, F is 6. So at A, I'll write down here, at point A, F is equal to 6. Okay, and we have already calculated the value of slope, that is minus rho L Ag, that is minus 20. So the value of minus rho L Ag, it is minus 20. So we can find out the value of F. And you can substitute this in this equation. This is F naught minus rho L, in fact, this is rho L Agx. The value of x at point A will be this one. So this is 0.06. So you can see that it is 0.06. So the value of F naught will be F plus rho L A G into x. So the value of f naught will be f, which is 6, plus this is 20 into x is 0.06. So it would be 1.2. So f naught will be equal to 7.2. And we know that f naught is mg. So mass of the cylinder will be density into area into length, complete length, and g. Okay, and if we divide f naught with this rho L A G, then it would be rho W A L G divided by rho L A G. Cancelling A G, you can see that it is rho W L by rho L. And the value of f naught is 7.2, and the value of rho L A G is 20. So now the value of rho W upon rho L will be equal to 7.2 upon 20 into L. And L is given as 0.3. So this is 0.3. So it is 72 upon 3, which is 24, and 24 by 20, 24 by 20. So it would be equal to 1.2 approximately. Okay, so this will be the correct answer in this case. Now we move on the next question. In this question, you can see that a group of students investigate how the resistance R of a metal wire changes with the temperature. And the students make an insulated wire from a metal into a coil, and the coil is placed in a hot water, and it is connected to the circuit as shown. Now the temperature of the air in the laboratory is 20 degrees Celsius, and you can see the circuit diagram here. Now as water and the coil cools down, the students measure the temperature T of the water and calculate the resistance of the coil. Okay, now they have plotted a graph how R varies with T, and the error bars for each value of R in the graph is plus minus 0.04 ohms. So you can see that this graph is plotted between resistance and temperature, while resistance is measured in ohms and temperature is measured in degrees Celsius. And you can also see that the marks are not equally spaced in the graph. Now there is a data point that is missing in the graph. When the temperature was 54 degrees Celsius, the potential difference across the coil was 0.950 volt, and the current flowing in the coil is this is 263 milliampere. Now we have to find out the value of the resistance from this missing data point. So we can obviously say that the R will be equal to V by I, and V is equal to 0.950, and in amperes I is 0.263. So it is approximately 3.61 ohms. So this is the value of resistance which is calculated from this missing data point. Now in this second part, you can see that we have to draw that missing point and the best fit line for the data. I've already marked this point. You can see that at 54 degree Celsius, this is 54 degrees Celsius, the value of resistance is 3.61. We already know that this one column is of 0.04 ohms. So the value of resistance is 3.61. So 3.61 would be somewhere like this. So this would be the point. And if I draw the best fit line for this data, then it would be like this. Okay. Obviously, this data has errors because this these points are not equally spaced. So this is a best fit line for this set of data. Now, students waited for 5 minutes between taking each reading, and this produced an unequal spacing between the points on the graphs. We have to suggest that what this implies about the rate of heat loss from the liquid and the coil. Obviously, we can say that eventually when liquid is cooling down, its temperature is decreasing. And you can see that between two successive points, the difference of the temperature is, you can see like this. It is continuously decreasing, which means that the rate of cooling is decreasing as the temperature of this water and coil is approaching to the room temperature. You can see that obviously I'm marking this. The difference in the first two readings is this one, and the difference in the second readings is this one. It is somewhat less, and then it is lesser, then it is also lesser. So we can say that as the coil and water cools down, their rate of cooling is continuously decreasing as their temperature is approaching the room temperature, which is the temperature of laboratory, or I can say the lab temperature. And the rate of cooling or heat loss is not uniform. And in the second part, it is we have to suggest one way to modify the experiment that will improve this graph. Obviously, they are taking the reading after each 5 minutes. So taking the reading in equal interval of time is the reason of this asymmetric graph, because the rate of cooling is not constant. So instead of taking the reading at equal interval of time, they should take the reading at equal difference of temperature. So the modification which is suggested is the fact that instead of taking the reading at equal intervals of time, they should take the readings at equal intervals of temperature. Okay, so that the non-uniformity on the graph on x-axis decreases, because if they are taking the reading at equal temperature interval, then this gap will be uniform on x-axis. Okay, so this is the modification which is suggested to improve this graph. Now, students measures the dimensions of the wire after the experiment, and the length of the wire in the coil was 2.50 plus minus 0.01 meter. And the cross-sectional area of the wire was calculated to be 1.43 plus minus 0.01 into 10 raised to power minus 8 meter square. Assuming that these values do not change over the temperature range used in this experiment, the students calculated the resistivity rho of the metal, and the resistance R is given by rho L by A. So at temperature of 50 degrees Celsius, we have to find out the resistivity. So obviously at 50 degrees Celsius, the value of R
you can see that the value of resistance at 50 degrees Celsius is this is the value of resistance, which is uh, 3.6 minus 0.04 at 50 degrees Celsius. Okay, 3.6 minus 0.04. So it would be 3.56. So the value of R would be 3.56 ohms, and the value of L, the length of the coil, is 2.50, and the area of cross section is 1.43 into 10 to the power minus 8 meter square. So the value of rho will be equal to R A by L. So R A by L, you can see that if we substitute the value, R is 3.56 and L is, in fact, A is 1.43 into 10 to the power minus 8, and the length value is equal to 2.50. So the value of resistivity will be approximately 2.04 into 10 to the power minus 8 ohm into meter. Okay, now we have to find out the fractional uncertainty in the resistivity of the metal. So we know that rho is equal to R A by L. So d rho by rho, using the formula of uncertainties, will be equal to plus minus dr by r plus dA by A and plus dL by L. Okay, so the value of the error in resistance is 0.04. It is mentioned in the question itself. The value is 3.56, and plus the error in the measurement of area. You can see that this is the error in measurement of area, which is 0.01, and it is 1.43, and plus the length is 0.01 upon 2.50. So this will be approximately 0.022, or we can say that it is equal to 2.2%. Okay, this is the fractional uncertainty or percentage uncertainty. Now, in the third part, we have to find out the value of resistivity with errors and with appropriate SI units. So we know that d rho by rho, is 0.022. So d rho will be equal to 0.022 into rho, and the value of rho is 2.04 into 10 raised to power minus 8. So this value comes out to be approximately 0.05 into 10 raised to power minus 8. So the value of rho will be equal to 2.04 plus minus 0.05 into 10 to the power minus 8, and the unit will be ohm meter. Okay, now in the next part, in this part, that when the students finished the experiment, they checked the thermometer by placing it in stilled mixture of ice and water. The thermometer showed a reading of -6 degrees Celsius, and student then drew the correct graph of R against T. State the type of error in the thermometer. Now, when the students finished their experiment, they checked the thermometer by placing it in stilled mixture of ice and water. The thermometer showed a reading of -6 degree Celsius, in fact minus 0.6 degree Celsius, and student then draw a corrected graph of R against T. We have to state the type of error in this thermometer readings. Obviously, the thermometer is reading each temperature with an error of minus 0.6 degrees Celsius, which means that it is reading each reading by a value which is less than by a value less by 0.6 degrees Celsius, which means that thermometer consistently reads zero point 0.6 degrees Celsius too low at every temperature. So this is obviously a systematic error. We know the reason of this error, so we will classify this as a systematic error. Okay, and in this B part, if we have to compare how original graph compares with the corrected graph, so we know that since the thermometer underreads by 0.6 degrees Celsius all the original values of temperature are too low by a fixed amount. Okay. And therefore the corrected graph will have same gradient and the shape, but it would be shifted by 0.6 degrees Celsius to the right. Right means to the higher value of temperature, towards the higher values of temperature T, which means that a horizontal shift will be there. Therefore, a horizontal shift will be there without changing the value of resistance. So guys, this was the complete solution of this paper 1B, and I'm in the continuous process of making the solution of other papers also. Please share this channel and subscribe so that I am encouraged and I would be bringing more precious content for IB preparation in the future. So subscribe this channel and please spread and share this channel to your friends, because it would help them in their preparation and it would also boost my morale. Thank you.